Today's video is the first section in chapter 4 known as the chain rule. There are lots of rules for differentiation. So we've done product rule, we've done quotient rule, product quotient, what else have we done? Power rule. So today we're going to talk about the chain rule. So the first thing I'm going to do is let's just do a basic derivative given y is equal to the quantity 2x minus 5 squared. So one way I'm going to do it is just to simply multiply out 2x minus 5 quantity squared. And that's going to be 4x squared minus 20x plus 25. And then the derivative of this, so the derivative of y with respect to x using the power rule is 8x minus 20. All right, so that's one way to do it. Another way to do it is to use a u substitution. So a u substitution is as such. I'm going to say let u equal 2x minus 5. So this would be y equals u squared. Okay, so the derivative of y with respect to u is 2u. Agreed? The derivative of y with respect to u by the power rule is 2u. Okay, now if I take the derivative of u with respect to x, so the derivative of u with respect to x is 2. Okay, so dy dx is equal to du dy sorry, that should be dy du. I have it backwards. Sorry about that. Should be dy du times du dx. So you just see if I were to reduce this, I would reduce the du's and I would be left with dy over dx. So why am I doing this? I'm just showing you it's another way to find the derivative. So dy du is 2u, but u is 2x minus 5. Again, dy du, power rule, 2u, and then u is 2x minus 5. So 2 times 2x minus 5 times du dx, which is 2, and that's going to give us 8x minus 20. Yeah, 8x minus 20. So same answer either way. Which one's faster, it really doesn't matter, but we're going to start doing powers to the fourth power to the fifth power, or we're going to start doing, what do you call them, trig functions. So it's going to be helpful that we know a bunch of different ways. All right, so let's do another problem, and we're going to do it a couple different ways. So let's say that you have, so this is a new example. Let's say that you have y equals x squared minus 2 cubed. Okay, so I'm going to do the u substitution for this problem. I think it's less work. So I'm going to say let u equal x squared minus 2. Okay, so this is going to become y equals u cubed. So the derivative of y with respect to u is 3u squared. And remember, u is x squared minus 2. So this becomes 3x squared minus 2 squared, just substituting in. Okay, and then let's find du dx. So I'm finding the derivative of u with respect to x, which is 2x. Okay, so the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x, and so then the du's would reduce out, so you can see these are indeed the same thing. So essentially what we're doing in this problem and in the previous problem is I'm finding the derivative in two steps, in two pieces, and then I'm putting those pieces together. So the derivative of y with respect to u was 3x squared minus 2 squared. The derivative of y with respect to u. Now the derivative of u with respect to x is 2x. So in total, the derivative is the derivative of this given function. Again, we did it in separate parts with a u substitution. I don't know why we use u. We always use u. Like, why is m slope? I don't know, because someone said m was slope. So this is 6x x minus 2 quantity squared. Okay, I do want to do this problem the long way, so lucky for you, I remember my Pascal's triangle, and so you're not going to have to do all the work of multiplying this out. So if you go to the previous example, where I multiplied 2x minus 5 quantity squared, and I multiplied it out, I'm going to do the same thing here for x squared minus 2 quantity cubed. If you remember your Pascal's triangle and you multiply out using the binomial theorem, and it's 1, 1, 1, 1, 3, 1, 1, 4, 6, 4, 1, etc. So I'm going to save you the trouble because I already did the whole thing. So when you multiply this all out, you end up with 6x to the 5th minus 24x cubed minus 24x. Nope, that's not true. This is the derivative. I skipped a step. Let's go back. What I just wrote down was the derivative. Okay, let's try that again. When you multiply this whole thing out, you get x to the 6th. That would be 6x to the 4th. It's for 12x squared. And then minus 8. And this should be a minus sign right here. Okay, sorry about that. I skipped a step and just went straight to the derivative. If you were to multiply out x squared minus 2 quantity cubed, this is what you would get. The derivative, using the power rule, is 6x to the 5th minus 24x cubed plus 24x. Okay, factor out looks like how much? A 6x? When you factor out a 6x, you are left with x to the 4th minus 4x squared plus 4. Okay, so when you factor, you get 6x x squared minus 2 quantity squared. Same thing. Great. Guess what? There's a shorter way for all of this, and it's the topic for the lesson, which is the chain rule. You can find the derivative of x squared minus 2 quantity cubed in one step. Ms. Babiak, why do you make us learn it the long way? Because I'd like to torture you. It's my job. All right, x squared minus 2 quantity cubed. Let me just move this up a little bit so you can see it better. Okay, so we have this beautiful rule called the chain rule. And the chain rule says that the derivative with respect to x of some function u to the n power is equal to the power rule n u to the n minus 1, okay, that's the power rule, times the derivative of u. And I will explain that in more layman's terms in a minute. So if I want to find the derivative of x squared minus 2 quantity cubed, take the derivative of the whole function. So this is going to become 3 times the quantity x squared minus 2 squared. Took the power, brought it in front, made it a coefficient just like we've done, and comes in front. Decrease the power from 3 to 2, and then take the derivative of what's inside. That's what I call it. So what's inside is x squared minus 2. So I need to take the derivative, using the power rule in this case, of x squared minus 2. So this becomes 3 x squared minus 2 squared times the derivative of x squared minus 2, which is 2x, which is in turn 6x x squared minus 2 squared. That is the chain rule. The derivative of the entire function times the derivative of quote unquote what's inside. Okay, so let's do a couple more examples. Let's practice with our trig functions. The derivative of sine is cosine, derivative of cosine is negative sine, blah, blah, blah. So let's practice those. So let's say I want you to find the derivative. So find the derivative of y with respect to x of the sine of 7 minus 5x. Okay. So I'm going to do this using a u substitution, and I'm also going to do it using the chain rule. Which one is better? At this point, it doesn't really matter. You should do whichever one you're more comfortable with. I'm going to first do it as a u substitution. So I'm going to say let u equal 7 minus 5x. So if u equals 7 minus 5x, then y is going to be equal to the sine of u. Okay, took out 7 minus 5x, I did a u substitution, I plugged it in here. Okay, so the first thing I'm going to do is I'm going to find the derivative of y with respect to u, which is the cosine of u. Okay? All right, well, we know u. u is 7 minus 5x, so this becomes the cosine of 7 minus 5x. Okay, and then I'm going to find the derivative of u with respect to x. So the derivative of u with respect to x, the derivative of u with respect to x is negative 5. Okay, so dy dx is equal to dy du times du dx. dy du is cosine 7 minus 5x. Du dx is negative 5. So this is equal to negative 5 times the cosine of 7 minus 5x. That is not the chain rule, what I just did. What I just did is not the chain rule, it's a u substitution. All right, so how do you do this using the chain rule? All right, so same problem. Y is equal to the sine of 7 minus 5x. Okay, so I'm going to take the derivative of this whole function. And the derivative of this whole function, the derivative of the sine of blah, the derivative of the sine of whatever it is the cosine of whatever it is. Okay? The derivative of sine purple is cosine purple. The derivative of sine Portia is cosine Portia. But now I need to take the derivative of the function inside, and the derivative of 7 minus 5x is negative 5. Try and squeeze that in there. Okay? How much work do you need to show? You know, right now, not much, but they are gonna, of course, get a lot more complex. Okay, I'm gonna do a problem with position. I'm gonna do a problem with position. So if you'd like to follow in the book, this is number 10. This is number 10. Okay, so you're given that an object is moving along the x-axis. Its position at any time t is given by s of t. Okay, so here we go. You are told that the position of this function is s equals t times the cosine of pi minus 4t. I'm pretty sure I have that written down right. Okay, and then we're asked to find the velocity as a function of t. Okay, I'm going to use the product rule in conjunction with the chain rule. Product rule in conjunction with the chain rule. Product rule says t times the derivative of this mess okay, so t times the derivative of this plus the second function, cosine of pi minus 4t, times the derivative of t, which is 1. So this is nice. No derivative, nothing to find. So here's what I have to do with the t derivative of cosine quantity pi minus 4t. Okay, so the derivative of cosine is negative sine. So it's negative, because this is derivative of cosine's negative sine of the t, times the sine of pi minus 4t. Derivative of cosine is negative sine. And remember, the derivative of cosine purple is sine purple. The derivative of cosine Portia is negative sine Portia. But then you need to take the derivative by the chain rule of the quantity of theta, in this case, which is pi minus 4t. So this is going to become the derivative of pi minus 4t is negative 4. The derivative of pi minus 4t is negative 4. So if I take out the negative 4, this becomes positive 4t times the sine of pi minus 4t plus cosine pi minus 4t. All right, that is the velocity of some particle at time t along this curve. All right, I want to do one more with a much funkier, I think, a harder derivative. So we're going to do it with a harder derivative. Actually, maybe we'll do two more. It's a longer video on the longer side. Of course, you can fast forward. So I'm going to look at number 14, where we're supposed to find dy dx, and the directions say check it on your calculator, which of course you can pretty easily do. So we are given, this is number 14, y is equal to the cosecant of x plus the cotangent of x, all to the negative 1. I don't like this negative exponent, and there's cosecant and there's cotangent, and this is kind of messed up. So I did a u substitution. You don't have to. You can just start using the chain rule right off the bat, but it gets pretty harried with the cosecant and cotangent. So I said, let u equal the cosecant of x plus the cotangent of x. So if that's true, then y is u to the negative 1. Okay, so dy du equals negative u to the negative 2. And then we know that u is cosecant plus cotangent. So this is going to be negative cosecant plus cotangent all over cosecant x plus cotangent x squared. Okay, and then we'll reduce that in a minute. Okay, u is cosecant x plus tangent x. So du dx, the derivative of cosecant is negative cosecant cotangent. And the derivative of cotangent is negative cosecant squared. Oops. Okay, so that's my du dx. All right, I'm going to reduce this before I go any further. Sorry, this is not very neat. My apologies. So dy du is negative 1 over cosecant x plus cotangent x. Okay, so dy du times du dx is equal to dy dx. Okay, so dy du is negative 1 over cosecant x plus cotangent x. And then du dx is negative cosecant cotangent minus cosecant squared. Okay, I'm going to factor. So if I factor out a negative 1 times the 1, so if I factor this, I'm going to get cosecant times cotangent x plus cosecant x And then, so remember here, I just factored out a -1 times the -1, all over cosecant x plus cotangent x, which is cosecant x. Okay, so that's enough for one video. I will post another one shortly.